Good evening class. In this segment I am going to explain that how vector can be explained or expressed in the space. Okay. So in the coordinate system we better know a frame of reference I am taking in which the rectangular components are there. Okay. So this is our frame in which this is our x axis, this is y axis and this is z axis. Okay. So let us suppose if we need to denote a particular point in the space. Okay. So let us suppose there is a point P in the space. So to represent any point in the space, what is needed? There is a needed of what? Coordinates, and x axis, y axis and z axis. So let us suppose there is a coordinate of this particular point P is x, y and z. X, y and z. So you know what is the meaning of this x, y and z? Means if I want to reach this particular point, so I have to move x unit in the x axis, y unit in the y axis and the z unit. Let us suppose this particular point is somewhere here. Let us suppose this is a tip and this is your point P. So if I want to just denote particular this point, so I needed somewhat x, y and z coordinate. Okay. So these three coordinates explain or express any point in the space, and this is in z axis I can take as z. Now I am just going to interpret the use of vector in this coordinate system. Okay. So you need to understand the role of perpendicular unit vector. We have to understand that what is the use of this perpendicular unit vector. Okay. So in a very simple language, to denoting a particular x direction, we needed some more notation, and that notation is what? I cap. I cap is a unit vector which denotes unit magnitude, which denotes the unit magnitude in positive x direction. This is very important thing that we have to understand. This all notation of the vector in this particular coordinate system. So what is I cap? I cap is simply, it is just unit vector which gives the unit magnitude in the positive x direction. So let us suppose if the displacement in the positive x direction is 3 unit, what? 3 unit. And just for example, let us suppose if the displacement in the positive x direction is 3 unit. So how we can express? By the help of vector. For representing this positive x axis, we have to use I cap. Okay, but I cap gives the unit magnitude, but for this particular example I have taken what? 3 unit. So how we can express in the vector form? 3 I cap, because I cap itself representing the single unit, but there is a 3 unit, that is why we have to multiply with 3, where 3, you see here 3 I cap. This is our vector. How? 3 is the magnitude and I is the direction, and we better know that always vector is represented by the magnitude as well as the direction. So if I am writing 3 I cap, so it is a complete vector. Why? Because 3 is the magnitude and I cap is the particular direction. What is the denotation of I cap, or what is the meaning of I cap? I cap represents the positive x direction. I cap represents the positive x direction. Let us suppose if it is written 3 minus I cap. What? 3 minus I cap. It means minus, if I cap represents the positive x direction, then minus I cap represents the negative x direction. So 3 I cap will be represented like this, where 3 is the magnitude and minus I cap is the direction, which denotes the negative x direction. Okay. Same. J cap. J cap is the unit vector which denotes the positive y direction. What? Positive y direction, because we can just write it J cap is equals to what? 1 J cap. So 1 is the unit magnitude and J cap is the directive vector which denotes the positive y direction. Okay. And K cap. K cap denotes the positive z axis direction. Here I cap, J cap and K cap are the directive unit vectors. Why it is called directive unit vector? The reason behind it, because it gives the direction and having the unit magnitude. Because I cap means 1 I cap, J cap means 1 J cap and K cap means 1 K cap. So all having a single unit magnitude, but it gives the particular direction. Let's suppose if I cap is written only, it means positive x direction it is denoting. If it is written J cap means positive y direction it is representing. If K cap is there means positive z direction it is representing. Okay. So this is important to understand that what is the use of this directive vector. Directive vector always gives the direction and this is the coordinate system. So vector can be replaced okay. Now come again in the beginning portion. This point P having the coordinates x, y, z means in x axis it having x magnitude, in the y direction it having y magnitude, and somewhat in z axis displacement or location is at z distance. Okay. So if this particular point, if we need to explain by the help of the vector, so how we can explain it? For denoting a unit positive direction in the x direction, we use I cap. For y axis representation, we use is J cap, and for the z axis representation, positive z axis representation, we use what? K cap. So how we can write it? If we need to express this particular position of this point, so how we can write? Here x is the magnitude which is in the positive x direction. So we can write x I cap. Okay. Y is the magnitude of the displacement or the position in the y direction. So how we can write? Y J cap. And z is in the z direction, so we can write z K cap. Okay. So if we need to explain this particular point by the help of the vector, so we can write, let's suppose any vector, we can just consider a vector which gives the position of this particular point P. So we can write what? xi plus yj plus z cap. This is the normal representation of the vector, which is useful for the understanding the coordinate system also. Okay. By the help of the coordinate, we can just substitute the ijk cap, which gives the particular direction in the particular axis. So we can just replace it and we can just get the result. So it is our normal vector representation in the particular space. Now by the one example, we can understand it. Okay, let's suppose this is our coordinate system, and at this particular point, let's suppose on the tip of this marker there is a point, and I'm just assuming this point as a P. Let's suppose at this particular point P, I'm applying some force. Okay, I'm applying some force, and it having some component in X direction, some component in Y direction, and some component in Z direction. So let's suppose this is a point A, and on which a particular force F is applicable. Particular force F is applicable at a point A. So how this force can be distributed in a different direction, that we have to understand. Okay, let's suppose Fx is the component of force in X direction, Fy is the component of this force in the Y direction, and Fz is the component of force in particular Z direction. So this Fx is applicable in X direction, this Fy is applicable in Y direction, and this Fz is applicable in Z direction. Means if we want to express our force with the help of the vector, so what is this? Fx, Fy, Fz. These are the magnitude of the force in different direction. But we better know, for expressing a vector we needed two terms. One is the magnitude and another one is what? Direction. So we need both the term. Okay. So magnitude we have, but the direction also we have. How we can just express it in vector form? We will use the I cap, j cap and k cap, which are the directive unit vector, which gives the particular direction in the space. So this Fx is applicable in particular positive x direction. So how we can write it? With the vector Fx I cap. Now it is complete vector. And for Fy, what we can write? Fy j cap, and for this Fz we can write Fz k cap, and our force F will be the sum of this all component. So that is Fx I cap plus Fy j cap plus Fz k cap. This is a general notion of this force in the space. Any vector can be projected in the different directions. Let's suppose I am just considering this particular plane xy. Okay, this is our plane xy, and there is a vector A which is making an angle theta with respect to the positive x direction. So if we needed to just project this vector in the horizontal and the vertical direction, or you can say in the x direction or the y direction, so we can just project this particular vector in its horizontal component, vertical component, or you can say in the x direction or the y direction. How? This you need to understand. Okay. Let's suppose if I am just drawing a perpendicular from this point on this axis, so it is our what? 90 degree. Okay, and I am just labeling it. This is a ABC right angle triangle. What? ABC right angle triangle. Now just see here. If I am just considering this particular right angle triangle and I am taking cos theta. What? Cos theta. So cos theta is what? It is the base upon hypotenuse. So base is what? Base is AC and hypotenuse is what? It is your AB. Okay. So how we can get the value of AC? AC is equals to AB cos theta, and in the AB direction, this is AB is our vector, which is what? A. So if I am putting, then AC will be A cos theta, means in this particular direction its component will be A cos theta. Same, we can just take sin theta in this particular triangle. So sin theta will be equal to BC upon AB. What? BC upon AB. From here we can get the value of BC, that is equals to AB sin theta. What? AB sin theta. Now AB means vector A, because this vector is denoting this particular line AB. So we can just write BC is equals to A sin theta. So this is our A sin theta. Now one thing which is important, this is AC, we can just take a parallel to this AC, a particular vector, I can just take it. Okay, so if this AC line is parallel to this particular line DB, then if A cos theta is applicable here, then A cos theta will be applicable here also. And if BC is parallel to AD, then here A sin theta will be there. So the one thing which is important to understand from this derivation, that is vector is A cos theta and A sin theta. See it carefully. A cos theta is the projection of this particular vector in the horizontal line, and A sin theta is the projection of this particular vector in the vertical direction. So horizontal and vertical component can be taken. Now how we can express this particular vector by the help of its horizontal and vertical component? This is also important. Okay, just see here what I have explained just now, that for denoting the positive x-axis with the unit magnitude we use I cap, and for denoting this vertical or the y-axis the directive vector is what? J cap. So just see here, our vector can be broken into two portions, horizontal as well as in the vertical. But just see here, A cos theta. What is A cos theta? A cos theta is the projection of this vector A in the horizontal direction. So means A cos theta is what? It is just magnitude in the horizontal direction. A cos theta is the magnitude of vector A in the horizontal direction. So A cos theta is a magnitude, but the horizontal direction, for denoting this horizontal direction or the x-axis we use what? I cap. So if I am just making it complete vector, so we use two things, one is the magnitude and other one is direction. So magnitude we have A cos theta, and the directive vector for the horizontal direction is I cap. So complete term will be A cos theta I cap plus A sin theta is the projection or the magnitude of this vector in the vertical direction or in the positive y-axis direction. So A sin theta is the magnitude and the directive vector is J cap. So now our vector can be represented in this format. This is very important, you need to understand it, okay? That this is the representation of any vector with respect to its horizontal component and the vertical component. This is our horizontal component and this is our vertical component. So this is how we can just express our vector in the space, okay? This is a normal representation of the vector in the space. Always we need to just take a directive vector for the representation in the particular space, where three terms are important, three things are important. You need to know that what is the use of I cap, J cap and K cap for the representation of vector. I, J, K all are unit vector, or we can say directive vector. They just denote the particular direction in the space. For representing the positive x direction, we use I cap. I cap gives the unit magnitude in the positive x direction. Whatever the magnitude of the vector, we have to simply multiply with I cap for denoting the x direction. Okay, and j cap represents the positive y direction with the unit magnitude, and k cap represents the z axis positive direction. So I hope that this is somewhat helpful for you. Just thank you and stay tuned with our channel. Thank you, class.